So hi everybody, and we'll have this module for today, which is the EIGRP. In this module we will divide it into multiple chapters. The first chapter will be about the EIGRP topologies and terminologies, and then we will go on with some examples on EIGRP. After this we will have one full big example with all questions and answers to solve an EIGRP routing and to make it well understood. So let's start. What's EIGRP at the beginning? EIGRP stands for Enhanced Interior Gateway Routing Protocol. Actually, EIGRP doesn't use any TCP or UDP. Instead, it's using IP protocol number 88. EIGRP also is not a distance metric nor an OSPF protocol or a link state protocol. EIGRP uses a protocol called diffused update algorithm to calculate the shortest path to the destination within the network. So EIGRP, we can say it's a mixture between the distance vector and the link state protocols. Okay, let's see what's the advantages of EIGRP. It's a very low usage of network resources during normal operation because it sends only hello packets on the stable network. If there is updates or changes on the network, it just sends the updates. Also, it doesn't send the full routing table, it sends the updated table only and the changes. Also for the rapid convergence times in the network topology, because for example if we say rep takes around 3 times the whole time to change or to update its routing table, which takes around 90 seconds or 180 seconds, as it's 6 seconds, and then 3 times it's 180 seconds. For the EIGRP takes around 15 seconds or less. Okay, now let's have an example between the EIGRP and the distance vector. Okay, for example between RIP and EIGRP. This is the sample of the network using RIP. For router B, for network A to reach network B, it should be routed as per the hops. The maximum through router A is 2 hops. Through router C it will take 3 hops. So the routing will move from router B to router A, and then from router A to router E. Okay, if router E fails now, if router A fails, what we'll have is that there is no information about any updates, and we have to wait 90 seconds until the convergence time, which is 3 times whole timer of 30 seconds. Okay, now what will happen after the 90 seconds? The route will be redirected through router C and then router D and router E. Okay, now let's have the same example for EIGRP. Okay, now EIGRP sends a hello timer of 5 seconds on every interface that's subscribed on EIGRP, and the whole timer of 15 seconds in each hello message. This means that the hello messages are sent every 5 seconds, and this can be changeable, but these are the default values. These values on the high bandwidth networks, on the LAN for example, but on low bandwidth and WAN networks the default is 60 seconds. Okay, every hello message sent, there must be an acknowledgement sent from the nearby router. Okay, and then when the acknowledgement sent, the nearby router, which is router A, sends the hello timer. The same, and after they exchange the hellos for the first time, which they don't know each other, we call it an adjacency. So we have an adjacency operated between the two routers, and they exchange the full routing table. The same here between router B and router C. Okay, now when router B receives the full routing table from router A and receives the full routing table from router C, we can see it builds the topology table. The topology table now is having the route to network B through router A, which is the successor, and we have a backup route through router C, which is the feasible successor. So we have in the routing table a successor and the feasible successor. The successor is the main route to the network, and the feasible successor is the backup route. So when one more thing, we can say that EIGRP uses the multicast address, can be multicast, the updates and the hello timers can be multicast or unicast. Multicast through the address 224.0.0.10, and unicast it can be by using static EIGRP neighbors, and we'll show this in the future. Okay, now let's see the same example. If router A fails on EIGRP, we'll find the hello timer is sent and no acknowledgement was received, so it will wait for the whole timer, which is the 15 seconds, and then the topology table changes and router C will be its successor as the messages, and then we have the partial updates or status changes. If there is new updates as router A is failing, so it sends only the partial update to router C that router A is not a valid route. Okay, hold timers and hello timers can be configured under each interface which is subscribed in the EIGRP. Take note that if we have passive interfaces, we cannot configure the hello timers and hold timers. Okay, we have the two commands: IP hello interval EIGRP, the AS number for the EIGRP and the number of seconds. Also the same for the IP hold time EIGRP, the AS number and the seconds. Okay, now let's see what the nodes of EIGRP. EIGRP does not build relationship over secondary address, so it only builds over the primary address. If we have an interface with two addresses, the primary address and the secondary address, we cannot have an EIGRP neighborship over the secondary address. When configuring EIGRP over a multi-access frame relay network or point to multi-point, they configure the broadcast keyword in the frame relay map statements. Without the broadcast, adjacencies wouldn't establish between two EIGRP routers. EIGRP neighbors can be statically assigned, as I stated before, using the command neighbor and then the IP address of the neighbor and the outgoing interface under the router EIGRP. Okay, what's the limitation? Actually, there is no real limitation for EIGRP or the number of routes it can hold, but it depends on the device itself, as the memory capacity, the processing power, amount of exchange information, number of routes sent, topology complexity and network stability. Okay, now we will move on to the EIGRP table. Before the router can send any EIGRP topology information to the neighbor, the router must have some topology data in its topology table. Router's EIGRP process adds to its local table without learning the topology data from an EIGRP neighbors from three sources, which is the direct connected subnets of the interfaces which EIGRP has been enabled on that router using the network command. 2. The subnets connected to the interface referenced in the EIGRP neighbor in EIGRP using the neighbor command if we have a neighbor. 3. The routes learned by redistribution of routes into EIGRP from other routing protocols or routing information sources. Okay, now let's see the topology table, what it contains in its table. we have the following. The topology table builds a set of distances and vectors to reachable networks, including the lowest bandwidth on the path to this destination as reported by the upstream server. Okay, so what we say in this, it means that if we have a 100 mega interface which is subscribed and another interface in the past having 56k, so when we calculate, we use the lowest, which is the 56 kilobit per second instead of the 1 meg. The total delay, we have to calculate the total delay over the path. Okay, the path reliability, if it's reliable or it's moving up and down, the path loading or the load of the path. Okay, and the minimum path and maximum transmission unit, feasible distance and reported distance, and the root source, external routes are marked. Okay, we will come into the feasible distance and reported distance soon. Now we'll move on to the EIGRP metrics. As we said, EIGRP uses the minimum bandwidth on the path to the destination and the total delay to compute the routing metrics. Okay, but you can configure the other metrics, but it's not recommended as such routing loops could happen in the network. We can configure the routing metrics using the command EIGRP metric. As we said before, EIGRP metric, you can use multiple other values other than the bandwidth and delay, and it can be configured using the command default metric, which we will come to it later in this chapter. Okay, the metric, as you see, the formula is K1 multiplied by the bandwidth plus K2 multiplied by the bandwidth divided by the K2 multiplied by bandwidth divided by 256 minus the load on the link plus K3 multiplied by delay. All the up formula is multiplied by K5 divided by the reliability plus K4. The defaults are K1 equal to 1, 2, 0, 3 equal to 1, 4, 0, 5, 0. Okay, then the final formula is K1 multiplied by bandwidth or bandwidth plus delay. Okay, what's the configuration of the bandwidth? The bandwidth is, we can see it's a 10 million, which is a 1 gigabyte divided by gigabit, divided by the bandwidth or the lowest bandwidth over the link multiplied by 256. Okay, and the delay is the sum of the delays in microseconds multiplied by 256. So we can have, here's the diagram, router B and router C are advertising the reported distance. We can see here is the bandwidth between router A and router B to go to network A. From router A to go to network A, we have the bandwidth is 56k and the delay is 2000 between router B and router A. On the other hand, the bandwidth is 128k between router A and router C, and the delay is 1000. So if you calculated the metric, as we can see, between router A and router B, we can see the metric is 10 million divided by 56 plus 2200, which is the total delay on the whole link. 2000 here and then 100 and 100, okay, by 256 multiplied by 256, and we get the distance is 46277 486. Okay, now let's see from router A through router C. We have the 10 million also divided by 128 plus 1200, which is the total delay. Here's 1000, here's 100, and here is 100 also. We can see the total multiplied by 256. The total is 20307200, which is higher than the number from router A to router B, which is lower than the distance on router B, and then router A will choose the best path through router C. Okay, now let's move to the content of the EIGRP update messages. Okay, EIGRP uses 5 basic protocol messages to do its work: the hello, the update, the query, the reply, and the acknowledgement. Mostly the usage is the hello and acknowledgement and the updates. Okay, EIGRP updates messages contained in the following information. What the update message contains: the prefix or the subnet, the prefix length, okay, the metric components, if it's bandwidth, delay, reliability, load, and non-metrics items as the MTU and hop count. Okay, here we have an example for the update message. Here we have on the router interface F0/0 on the LAN with the delay of 10 and bandwidth 100,000. Okay, which means 100 megabits per second. And we have an interface S0/0.1 on router B. We have the delay 2000 and bandwidth 1544 kilobit per second. Okay, so when I'm sending the update, I'm sending the subnet, the delay, the bandwidth, the MTU, load, reliability, and hops. Okay, now I'm building the topology table. Okay, the topology table will include the subnet, the delay, the bandwidth, and also the other factors. And after building the topology table, I send the update to router C. But I cannot send the update to router C without building my topology table. Okay, now let's have a look at an example for the router topology table for the example that we said about the delay. Or let's move to this example. Okay, we can talk about this one. We'll have a small example on router A. Okay, let's see show IP EIGRP topology. Okay, we have the topology we have on router A, this one, the 192.168.1.0 network, okay, which is connected via fast Ethernet 00, and we need to go to 192.168.2.0/24, which is, let's see here, network A. Okay, we see the feasible distance as just calculated. Okay, we have one successor. Okay, and we have it via 2 interfaces. Okay, which is through router B and router C, but it defaults to router C. As you can see, the serial 0/0/1 or the second serial interface. Okay, this is okay. Now if we can see show IP route, and here is the routing. It's learned serial 0/0/1, but we have 2 routes in the topology table. Okay, now let's see the neighbors. So IP EIGRP neighbors. a mistake. We have two neighbors, okay, and here is the whole time and the details. Okay, now if we need to see the interfaces, so interface f0 slash 0, sorry, s0/0. We have here the bandwidth is 56 on the S0 and the delay is 20,000 microseconds, which is 2,000 milliseconds. Okay, and here's the reliability and the load. There is no load and the key packet. Okay, now show interface S0/0/1. We have the bandwidth is 128 kilobit and the delay is 1000 milliseconds, which is 10,000 microseconds. From this example we can see the demo about the routing. Also kindly note also that the bandwidth and the delay can be configured manually on each interface. For example, if you are having a serial interface which is a multi-point interface, not a point-to-point like frame relay, each sub-interface must be configured with its bandwidth, like the following command: sc interface S0/0 show running config. Okay, show config. Okay, we have here, if you can see, here is the S0/0 and S0/1, each configured with the bandwidth command, and here also configured with the bandwidth command and the delay command. So bandwidth and delay can be configured on each interface subscribed to not passive interface in the EIGRP. In the upcoming chapters, we'll also describe the security breach of EIGRP and how to overcome it using the authentication between the EIGRP peers and EIGRP neighbors. Thank you for listening very much.